Yes, welcome to Bison Plus. My name is Wow Chemist, and I'm going to take you through carbonyl compounds. As we stated it in introductory part, we say that this one here, they're also known alkynyls or alkenones. Or if you don't want to call them alkynyls, you call them aldehydes. Another name for alkynyls, aldehydes. Then we also say that alkenones or ketones. And then we say uh, these carbonyl compounds, they have what we call a functional group, and that functional group is what we call the carbonyl functional group, and it is this one. Take note. You see something like this in chemistry. Just now I'm dealing with carbonyl compounds. Then now they say it have the same general formula, So that's why you see this CN H2NO. Then these alkynyl, alkynyls, they have general, they have hydrogen atom attached on the carbon atom. This is what we call the carbonyl carbon atom. And that is, the carbonyl group is terminal. So that means when you look at these alkynyls, these examples, you will see that this carbonyl's functional group is terminal, is just at the end, So that means when you get in the middle, then that one there is something different. Then after you seeing that, they say it represented by this. So these are represent these other parts. This one, this part, this part. So that is it. But for ketones or for alkenones, they have a functional group in the middle of the alkyl group. So these are the alkyl groups, and you see the functional group in the middle. So let's look specifically now at what we call the carbonyl compounds. Take note, they have the same general formula, but different what? They have different when it comes to functional group. But carbonyl compounds themselves, they have this functional group called the carbonyl functional group. But when we say it for aldehydes or alkynyls, then you will see something like this. H and then this. But now when you come for ketones, be in position to see the two alkyl groups and this one carbonyl carbon atom in the middle. And that is the functional group for ketone. Okay, if we are good, we shall now focus on alkynyls and aldehydes. And these are the examples given. So here is just very simple for you to come out with methanol. You say it, you just come to this, the functional group is this. So we say it, from the general formula we have C, N, H2N, O. So instead of N, I will put 1. So if I say 1 times C, it will be C. Then now here I will say 2 times 1 is remain 2. So we shall have something like this. So if you don't want to write like this, you write like this. That's what we call methanol. So this naming we said you just replaced this E in alkanes. That's named systematically by replacing this by this. So this one is found in alkanes. And then this Al now is for carbonyl compounds, specifically alkynyls. So these are the examples, and you see the different IU names. Then lab preparation of alkynyls. So this one here, we need to know this chemistry very well, because if you're in the lab, you'll be in position to prepare this methanol. Is called methanol. And now this one needs correction. This one here is alcohol. It is ethanol. It is ethanol, not methanol to methanol. So this one here is supposed to be CH3, CH2, OH. H2OH. So if I have my ethanol, then I pass it over heated copper at this temperature, 300 degrees Celsius, I'll be in position to form what we call ethanol. I'll be in position to form what we call ethanol. Now, after you knowing how to prepare this thing from the lab, you'll be in position to continue and see their physical properties. After seeing their physical properties, you'll go to chemical properties, and then you continue. Now, when you look at this, at the physical properties, we are saying these alkyls, all of them are liquids, except this methanol, which is a gas. So that is explained by the increase of carbon atoms, which increase what we call the molecular mass of these molecules. So methanol is a gas, and alkyls are colorless and they have characteristic smell. So when we're doing alcohols, also said these alcohols, they have also what we call characteristic smell. Then we are saying most of these compounds, they are colorless. In the laboratory, when you go to the lab, you see them, they are colorless. That's why it's not appropriate for you to start going to lab and you start drinking, saying it is water. Drink other chemicals, though they will have different smells. Their solubility decreases down the homologous series. And the other day I talked about homologous series in the previous lesson, and we said this is a series whereby this molecule have the same functional group, okay? And at the same time, each molecule differ from each other by what we call CH2. So in that sense, you will see that difference. Then we are saying the melting and the boiling points of alkyls generally increases with increase in what we call the relative molecular mass. So that means when I'm here and I say ethanol, the melting or the boiling point of ethanol is less than the one of propanol. The one of propanol is less than the one of what? Of these 3-methyl butanyl. Why? Because of this increase in the relative molecular mass. Other atoms, they are added to it. Now, let's now single out ethanol alone. We are looking at this chemistry because that's what the syllabus emphasizes. So let's look at the chemistry of ethanol. Ethanol is colorless, of course, we know, and it is liquid. It has pungent fruity alcohol odor. And this odor here is, you smell it when you're in the lab, when you're dealing with this ethanol. It is also soluble in water. So that means the form what we call mist, you will see that will mix up together. But you will not be in position to distinguish and say this layer is for ethanol, this layer is for water. So it is soluble in water and has low boiling point of 20 degrees Celsius. So that means if I have my water, I have alcohol, and I have, okay, I have water, I have also, let's say, ethanol, and we say we also have ethanol. Yes, or here like this. If we have something like this, then this one here, the boiling point is 100 degrees Celsius. The boiling point for ethanol is 78 degrees Celsius. Then for ethanol, we have now learned today that it is 20 degrees Celsius. So when you mix this compound and start boiling them, you expect this one to boil fast, then followed by ethanol, which is alcohol, then water. So that's the knowledge you need. So let's come to chemical properties of ethanols. We said combustion, so burning, ethanol burns in plenty supply of oxygen and will be in position to get carbon dioxide and water molecules. Now you will also look at other chemistry like when oxygen is in limited supply, so for it to burn out to give for you carbon monoxide, and in the process we also produce soot, which is carbon. Then when we look at its effects on litmus paper, we are saying, oh, litmus, we have litmus solution and we have litmus paper. So this organic compound has no effect on litmus paper. So it was red, litmus paper, it will remain like that. If it was blue, litmus paper, it will remain like that. So that means this compound is neutral, it's not acidic, it's not basic. Let's meet in the next lesson.